Hello friends, welcome back to my channel Learn India 24/7. In this video, let's discuss and understand about process capability analysis. We will cover below topics. So let's begin. Process capability analysis refers to set of statistical methods developed to estimate the capability of manufacturing or service processes to meet a set of specification limits. Two data types are commonly used in statistical process control. In the case of variable data, measurements are made on continuous scale, such as dimension of manufacturing item or time required to perform a given task. In case of attribute data, observations are made on non-measurable characteristics, usually resulting in binary decisions like good or bad, pass or fail. The diameter of 100 medical devices were measured. The diameter should fall within range of 2 plus minus 0.1 mm. In this case, we want to estimate the percentage of atoms that would fall within this range. The US Highway Safety Department has reported that in 2014 there were 29,989 fatalities in motor accidents. During same time, the US Bureau of Transportation has reported air accidents data for all US air carriers. So now we are interested in comparing the performance of US air carriers with that of motor vehicles. The first step in analyzing any data is to plot it. For variable data such as diameter, plotting histogram is useful. A histogram divides the complete range of data into non-overlapping intervals and displays bars with height proportional to number of observations in each interval. The complete range of specification limits has been divided into 40 classes, and each bar indicates how many of 100 sample devices fall within each class interval. Also, please note that all 100 observations fall within specification limit, and secondly that there are more number of bars to the right of peak than there are left of the peak. While 40 class intervals are used in this histogram, the thumb rule is to use 10 into logarithm of sample size number of class intervals covering the range of observed values. In this case, 10 into logarithm of 100 comes to 20, which is close to the number of bars displayed in this figure. Friends, let's discuss now about descriptive statistics. Given the sample of n observations, it is used to calculate numerical statistics to summarize the data. The descriptive statistics is any number calculated from the given data. The sample of observations are represented using notation xi, where I is equal to 1 to n. The two most commonly used descriptive statistics are mean and median. The sample mean is simple arithmetic average of sample observations. And median is calculated by first sorting the data from smallest to largest, and in case if n is odd, the median is equal to a single observation in the middle, and in case if n is even, the median is the value midway between middle of two observations. The value mean represents the center of mass, whereas median is the value that divides the data into half. Let's now continue with the example of numerical device diameters. There are total 100 observations with mean value of 1.987 and median value of 1.984. Since the data points are positively skewed, it is common to have mean value greater than median. To summarize the amount of variability in the data around its center, the below mentioned three different statistics are used: sample standard deviation, the sample range, and interquartile range. The sample standard deviation is calculated based on amount of deviation of observations from the sample mean. The larger the variation of the data around the mean, the greater will be the value of standard deviation. The coefficient of variation is the ratio of standard deviation to mean. The coefficient of variation has no dimension, as it is a percentage ratio of two different statistics having same dimensions. The coefficient of variation is used to quantify the amount of error in a measurement process. The interportal range is used to measure the variability of data by calculating the distance between 25th and 75th percentile values. The 25th quartile is the middle value in the first half of the rank order data, and 75th quartile is the middle value in the second half of rank order data. In the case of medical devices data, the 25th quartile value is 1.976 and 75th quartile value is 1.996. Hence, the interquartile range value is 0.02. The medical device diameter data have sample standard deviation of 0.0179 and range value of 0.097. The coefficient of variation value 0.904% shows the standard deviation is approximately 0.9% of the mean. Two additional statistics often used to measure the shape of the data are as shown below. Skewness gives an indication of how symmetric the data points are. A symmetric distribution has the same shape to its right as well as left. Distribution with longer upper tails than lower tails are said to be positively skewed, while distribution with longer lower tail than upper tail are said to be negatively skewed. Kurtosis measure how flat or peak the data distribution is relative to bell-shaped normal distribution. The large value of kurtosis indicates peak distribution, while smaller value indicate flatter distribution. The commonly used statistics for measuring skewness and kurtosis are as below. The numerical values of G1 and G2 are difficult to interpret. The standardized skewness and kurtosis values are calculated as shown here. In large sample, these statistics values will fall within range of -1.96 to +1.96. Values outside this range indicate data does not come from normal distribution. Let's continue to understand the skewness and kurtosis values for medical device data. Standardized skewness and kurtosis values of 5.034 and 4.599, which are well above the expected range for normal distribution. Together, these two statistics indicate that data doesn't come from normal distribution. Friends, let's discuss about box and Whisker plot now. It was developed by John Turkey. It displays a 5-number summary. It has a box at the center, a line at median, and two whiskers extend into minimum and maximum values. In addition to vertical line at median, it has small plus sign indicating location of mean. The box plot also shows separate point symbols for the largest values, which are nothing but outside points. When the given data is discrete, different methods need to be employed to summarize it. The number of year accident is an example of attribute data. Let's use this data to determine whether the current air transportation system is capable of providing safe travel. There are several metrics that might be used to quantify the risk associated with air travel. One of the most common metrics used by International Civil Aviation Authority is equal to number of fatal accidents per 100 million flying hours. From the diagram, it is clear that rate of fatal accident has declined over a period of time. The main objective of performing capability analysis is to estimate the percentage of atom in a population that do not conform to specifications. These specifications may take the form of an acceptable range such as 2 plus minus 0.1 mm, Given a sample of 10 atoms, the important task is to estimate the proportion of atoms in the population that do not satisfy the product specifications. The proportion of such atoms will be denoted by symbol P. So friends, we have come to an end of this video. I have used a book, Process Capability Analysis by Neil Polhams, as a reference for this video. In the next video, we will discuss about capability analysis for proportion of non-conforming atoms. So friends, finally, if you have liked this video, do subscribe to my channel and do not forget to press on bell icon to get further updates from my channel. So at last, thank you for watching and bye.